Today is our third day solving quadratic systems of equations. And even though the problems look a little bit different in the notes, it's essentially going to act as a review because the process is pretty similar. You can see here that we have two equations. Both of them are y equals. So I can set them equal to one another. X minus 1, x plus 3 equals negative x squared minus 2x plus 3. Then what I'm going to do is I'm going to FOIL out as my first step. So when I FOIL, x times x is x squared, x times 3 is 3x, negative 1 times x is minus x, negative 1 times 3 is negative 3, and negative x squared minus 2x plus 3 was on the right-hand side of the equation. And then we're just going to solve like we normally do. So I'm going to get my quadratic equation set equal to 0 by moving everything over from the right-hand side. Combine like terms, so x squared plus x squared is 2x squared. I have 3x plus 2x minus x, so all of that together gives me a 4x. And negative 3 minus 3 is a negative 6. Then I'm going to try to find the solutions. You should always try to factor first, and when you factor, you need to check for GCF. There is a GCF of 2 here, so that gives me x squared plus 2x minus 3, and that is the trinomial that I will be factoring. Using the factors of 3, which are 1 and 3, and different signs to get a positive 2, that'd be a positive 3 and a negative 1. So x minus 1, x plus 3. That gives me solutions of 1 and negative 3. Remember, those are just our x values. We need to write our answer as coordinates and plug it into one of the original. I personally think that plugging it into the first would be easier, but it's up to you. I'm going to scooch it over right here. When I have x equals 1, that's y equals 1 minus 1 and 1 plus 3. So that's 0 times 4, or y equals 0, meaning that my first coordinate is 1, 0. Okay? And when x equals negative 3, plugging that into my first equation, that's y equals negative 3 minus 1 and negative 3 plus 3. So that's y equals negative 4 times 0, which is 0, giving me a coordinate of negative 3, 0. So my only difference was I had to FOIL first and solve. Let's check our answer on Desmos real quick. Here you can see that we have negative 3, 0 and 1, 0. So those are my 2 points of intersection, or my 2 solutions. Number 2, we have 2 equations, both y equals, so let's set them equal to one another. And again, the only difference is we're going to FOIL first. Now we have to FOIL the one where it's an expression being squared. Remember, you cannot distribute that 2 because of that subtraction sign. So when it's addition and subtraction, you must FOIL. When it's multiplication or division, you can distribute that power. So over here, I could distribute the 2. I get 2x squared minus 4 equals, and I'm going to rewrite x minus 2 squared as x minus 2 times x minus 2. FOIL that out. I have 2x squared minus 4 equals x squared minus 2x plus 4. Combine like terms. Because I have a 2x squared here, I like to keep it so that it's positive. So I'll move everything here. It might be easier if I go ahead and combine like terms first before moving it to the left-hand side. So x squared minus 4x plus 1. So now I'm just subtracting an x squared, which gives me x squared. I'm adding a 4x, and that does not combine with anything on the left-hand side, so I'm going to leave 4x. And then minus 1. Negative 4 combines with negative 1, which gives me negative 5, equals 0. And I can factor this using the factors of 5, which are 1 and 5, and different signs to get a positive 4. That's x minus 1 and x plus 5. Or 1 and negative 5. It's up to you which one you would like to plug your x values into. I personally think that it would be easier to, well, it doesn't really matter. I plugged it into the first one when I tried it. I'll show you here. When x was negative 5, I plugged it into the first equation, which gave me negative 5 squared, or 25 minus 2, which is 23 times 2 and 46. So that point was negative 546. And then over here, for x equals 1, I plugged it into the first equation, ended up with a negative 2 for the y value. Let's check Desmos and see what this looks like. When you check your answer in Desmos, we can easily see the 1, negative 2, but we'd have to zoom out in order to see the second point of intersection because it's really high up there. So that would be at negative 546, which is what we had.